So yeah, Tobias Meyer, my name. I'm Business Development Manager at IEEE for the area of smart health. And today I would like to talk a little bit about how we use printed electronics in diabetic management. So, brief introduction of IEEE. We're a Luxembourgish company. We're mostly active in the automotive field as an automotive interior safety supplier. We're present in 9 countries, have more than 4,100 employees, and we work directly with about 80 automotive OEMs worldwide. We have a sister company called All Circuits. It's an electronic manufacturing service that, among others, is as well certified for medical production following ISO 13485. Okay. So IEEE started back in 1989 based on the previous operations of a company called Interlink Electronics Europe in particular. And we developed quickly into the area of automotive interior safety with our first product being the seatbelt reminder, in short SPR. The SPR is detects occupants in the front, passenger and rear seats, and enables the car to trigger a warning if passengers are not buckled up. Our initial portfolio was entirely based on screen printed sensing solutions, and we also started to venture into other areas like consumer electronics and healthcare right from the start, but nothing ever came close to our success in the automotive market. So everything else stayed niche. Test. Okay, niche from years. However, it became quite obvious. I think I have a little issue here. Okay. Oh. Take that out of my pocket, maybe. Okay. Touch it. No. Is it working? I'm talking. Oh. Yes. Where was I? So it became quite obvious that printing alone will be nothing for our company in the long range. So we started to focus on functional solutions and to deliver full lab-to-fab services. And this approach led us finally to a portfolio listed on the table on the left side. And we ventured also off and offer the range of screen printed, conventional hardware and hybrid solutions, and respective in-house competencies like material development, complex simulation, software engineering, and more, which is shown on the right side. And the center images, you can see some of our products, like the seatbelt reminder, the hands-on, hands-off detection, radar modules, and also our smart insole, to which I will come in a little bit in more detail. So at the end, it's always quite simple. Whenever people talk about IoT or Industry 4.0, the fact is that without sensors, you don't generate any data, and without data, there is no advanced analytics. And so this puts us, in our belief, in a good spot for the future, since sensors is our business. In an automotive field, the future seems to be with software-defined vehicles, SDV, means that at the end, the software, the applications you have installed in your car will finally define the use of your car, or will define how you use your car. And in addition, increasing amounts of different sensors placed inside the cabin can offer new functionalities and insights through sensor fusion approaches, allowing for even more application and safety features in the car. So now let's talk about our medical or smart health applications that we're working on and how our motive expertise helps us to advance in this new field. Since a few years, we are focusing on our development on smart insulin sensors mainly, which in its initial configuration are pressure sensors, enabling us to spread our activities across a wide range of medical applications. And interestingly, application of sensors inside a shoe comes with similar challenges towards sensors like our seat sensors inside a car. You must comply with a wide range of temperature ranges, wet conditions, high mechanical stress, and so on. Plus the foot is one of the primary interfaces of the body to its environment. There's a ton of conditions and situations you can find yourself in that have an impact not only on your way of walking, but also on the neurological pipeline from your brain all the way to the toes. And it's such a big range of applications that you really need to focus on select applications and features to not lose yourself and develop applications that are in theory capable of doing everything, but at the end don't solve anything really. Since especially the hardware platform is always the same sensors, same data that comes out, it's the way you analyze it. And you can monitor, for example, progressive neurological degenerative diseases like dementia, Parkinson, Alzheimer's. You can go into the rehabilitation field. You can check metabolic diseases like diabetes, sports medicine, well-being, obesity. All these are fields that you can be active in. So you see, it's a very wide range. A few years ago, we decided as a IEEE that we develop a kind of universal platform that can be combined with additional sensors to build up on our sensor fusion approach. But we wanted to focus on 3 key areas, which are rehabilitation, neurologic conditions, here especially Parkinson's, and most important for us, diabetic care. We're also open to collaborate with other companies, support their own product development. For example, a few years ago, we provided a sensor support with the integration for feeling prosthesis and for direct feedback system wearable for patients with peripheral polyneuropathy. And now what is it that we're actually looking for in the data of our system? So we detect pressure distributions and inertial movements, which allow us to get insights on a person's individual gait and balance, which we use to evaluate changes over time, to detect critical events, to identify possible avoidance strategies of patients. For example, is the patient going upstairs or avoiding stairs, taking the elevator, things like this that can point towards a medical problem. We assess fall risk and we evaluate the neurological health status of patients. And together with additional sensors like heart rate sensor, blood oxygenation sensor, ECG, we apply sensor fusion techniques and machine learning to not only gain more insights, but also tailor our platform better to the actual use case scenario that we're looking for. We are currently testing and evaluating as well new printed temperature sensors to expand our capabilities, especially for diabetes care in the area of pressure ulcer detection and prevention and potential issues with blood circulation. And so how does it help us with diabetes care? We are following different approaches there. As you may know, diabetes type 2 is a lifestyle-related or mostly lifestyle-related metabolic condition. About 10% of the population are diabetic, some regions more, some regions less, but in general, the curves are all showing up. 1 out of 3 adults already is considered to be pre-diabetic, which sums up to about 2 billion people worldwide, and the healthcare spendings are already through the roof. So there's a great potential. Even small changes can have significant savings. And what we're currently working on, our main product at the moment, is a method for early detection of peripheral polyneuropathy. For those of you that don't know, diabetics develop this very often, but also anyone else can develop it. You basically lose slowly all the feeling in your foot, and you don't get any feedback from there anymore. And in diabetic patients, about 50% of all diabetics, they will develop a polyneuropathy. And of those 50%, about 50% have no clue that they're even having a severe damages to their nerves. And so developing diabetic foot and losing complete feeling in your feet comes with a great risk of developing pressure ulcers, since there's no pain feedback anymore to the brain, and losing, at the end, you can lose your foot due to amputations. The good thing is that the earlier one detects the loss of this feeling, the earlier you can start special treatment. This can be as easy as applying vitamin B12, or just raising in general awareness that from now on you have to pay more attention to your feet care, everything, and with these small measures, it's possible to delay the effects of this disease, like losing the complete feeling and developing foot ulcers down the road, and you can delay it as fast as possible into the future. And to detect such nerve damage, we developed an application together with a partner in Germany that is using a gamification approach. So we're not looking at the gait here, we're looking at the neurological feedback while you're playing games. And we test your reaction to games that you control with your feet via our sensors. So we're looking, when do you react, how strong do you react, how constant do you react to the games. And after playing a few games for about 12 minutes, the system is capable of diagnosing the likelihood of having a polyneuropathy, the severity, the affected nerve fibers, and it can even conclude if this possible PNP is paired with the cognitive impairment of the patient. In the second step, we are focusing on the topic of treatment adherence. And I'm aware that this is a more sensitive topic in Europe, at least, to control patients' behavior and adherence to specific treatments. But it also seems to be a hot topic, for example, in the United States. And currently, research shows that about 50% of diabetics with even severe diabetic foot complications, meaning, for example, they're being at risk for developing pressure ulcers, they do not follow recommended treatments, which often means wearing these ugly shoes that you can see up there. One of the main reasons people don't wear them, because they don't look different to the environment. And by using our system into these shoes, we're capable of analyzing the gait and the activity, and it could be simple for us to find out in detail what the patient is actually doing with these shoes when he or she wears the shoes, or to find out if they wear the shoes at all. Health insurance has already expressed a lot of interest in such technology. They want to use it in a type of carrot and stick approach, meaning offering flexible health insurances to patients where adherence is rewarded and non-adherence is kind of punished. So, but now what challenges did we encounter so far? And I guess it's everywhere the same. When you start with a new project, you're excited, you look at the advantages, and you start to think that that's a no-brainer. We help people, we save costs, everybody will be happy, everybody must be happy. Of course, that's what it is. And that's when you realize that that's not the way it works. Some examples for the feeling prosthesis that we developed with the Austrian startup called Saphenos. It's a genius idea. You give people the feeling of their lost foot back, so they can feel their foot again. They can do things they couldn't do before anymore. There's no phantom pain anymore. But when you look closer, you face questions at the end, like who pays for that? Where's the money come from? It's an expensive system, costs several thousand euros. And who pays the people at the end that actually have to do the work to integrate it into a prosthesis? And who does the work actually later on? These are all questions you need to address before. Another example, everybody probably knows after surgery, you go to the doctor tells you don't put more than 10 kilos on your foot for the next 3 months. So what is 10 kilos? Nobody knows in daily life what is 10 kilos. And every year we receive requests from large manufacturers. Yes, we want sensors in our shoes and our boots for exactly that reason. Products in the market so far, I think is still zero. And why is that? That took us a while to figure that out. But it has mainly to do with patient data safety, GDPR, data ownership. Everybody's afraid nowadays of having patient data because of GDPR. Everybody wants patient data, but nobody wants to handle it. And then we have even ethical questions like, what if I don't follow the recommendations of the doctor and do whatever I want? Does the health insurance come later and say, you didn't do it, so we cut the payments for you? I would punish myself by giving access to my data. And that's a big problem. And at the end, it comes down to who pays for it. Like, that's always the question, to find the right person who pays for the treatment. It's not always the patient, it's not always the doctor, it's not even always the health insurance. And the systems we design, they have to be compatible with established processes at the end, in the doctor's office, with the workflows. They have to fit into the hospital work. If you have something that's completely out of line, it will never be adapted by anyone. So you have to figure that out from the beginning to work towards that. Then applications that you develop need to interface with existing patient software of the doctor. No doctor wants to have 20 applications installed. You don't think of that from the beginning as well. And very important, we need to work on raising awareness, educate doctors as early as possible, especially if you want to use later on AI in a clinical environment. One of the biggest problems we encounter, for example, with our peripheral early detection, the peripheral neuropathy early detection, is that most doctors are not aware of the disease, of the conditions. And the current standard actually exists. This takes about 1 hour for the whole procedure per patient. Our app does it in 12 minutes. That's great. But then you find doctors that say, I need 3 minutes. I don't need your app. Take it in 3 minutes. They're doing it wrong because they don't know any better. But that kills sometimes already your whole business case. Then you have reimbursement procedures, very tricky. That's why a lot of companies don't go to Europe, because very diverse scene of many health insurances. People look more to the US, to the Middle East, to the UK for this. But even there, you need to figure out where the money comes from at the end. Then health insurances itself, they look for different things. Like in Europe, prevention is a big deal, and you open doors there. Well, in the US, they sometimes don't even seem to care of prevention. They want to know, how can I save money now? So for them, treatment adherence is a big thing. And then at the end, you have regulatory questions. In many countries, the framework for the use of digital technologies does not exist yet, or is still being evaluated. First guidelines are being drafted. Especially use of AI is a big problem. Puts a lot of pressure on these guys, because simply you don't know what the AI does. You can test it maybe and evaluate the outcome, but you never really know. And once you take the step to open AI, there's no way to know anymore. So enough downsides. So what's the bright side? Where are our opportunities? If the fact that governments and health insurances, they will need to adapt. Pressure for saving money and increasing efficiency will rise. Larger push towards use of wearables and IoT applications will come. Regulations will accept AI applications sooner or later as well. Coming generations of doctors They will be more open and familiar with wearables, and hopefully will also have a better basic understanding of AI, and even patients will become more adept in using new technologies, will accept wearable more likely than it is today. And the example I brought earlier from Saphenus, they managed actually to provide a tool that increases the quality of life and prevention of follow-up conditions. Can also be used for diabetics after amputation. And their slogan is get back your life. And this can be seen literally. They successfully made first steps, started helping people. So that's a shining example, I think. Treatment adherence will help in the future, will help to reduce medical spendings and will improve the quality of life of everybody. Prevention of conditions and complications, like for example, what we are working on with our polyneuropathy product, will help to delay the side effects and secondary effects and the progress of polyneuropathy in this case. And for example, just last week, we were able to actually test a colleague of ours that has diabetes and was not sure if he develops a polyneuropathy or not. And we could help him and, well, unfortunately detect for him that he has a polyneuropathy in the early stages, but now we can get treatment for it and prolong the development of the condition. And that use of AI, of course, great opportunities in the future, specifically for sensor fusion systems to detect even more underlying conditions that are currently invisible to us. And then you have a societal development. You have an aging society that will yield in many more medical related problems. You will have more chronic diseases. We face a decreasing workforce. This will result in more expensive services, limited resources, and this will eventually force us to utilize the use of wearable digital devices in healthcare. And here's a small picture, I think, this from our polyneuropathy device, showing a little bit for the games you play. And you see below a lady that is already wearing the Saphenus prosthesis in real life. So there are promising developments. And from IEEE side, so how can we overcome at least some of the challenges that I just described to turn our opportunities into profit? At IEEE, what we're quite experienced in is actually using regulation to our advantage. We do this in automotive. Example, the seatbelt reminder. Over the years, the adherence of wearing a seatbelt rose to about 95%. If you look at diabetes, 50% are non-adherence. And the question is, can we do the same in healthcare? We improve the quality of life, and we can save money if we have to force patients through regulations or force insurances to pay for such technologies because regulation demands it. That's where we see our step, our opportunity, and taking small steps, even for diabetes, for example, can save huge amounts of money and can help people. But on the other side, regulation is the way to go, but changing regulations is a patience game. You need money, you need time, you need a lot of time to do it, but we were quite confident that we can go this way. And with this, I will finish my presentation. Thank you very much.